In this lecture, we will be discussing T-SQL, stored procedures, and user-defined functions. T-SQL stands for Transact SQL. It's Microsoft's extension to ANSI Standard SQL. Other database platforms have their own versions of this. Oracle's is called PL/SQL. T-SQL includes procedural programming components, such as variables and control flow, and it allows us to create stored procedures and user-defined functions. Stored procedures are one or more T-SQL statements that work together to perform a particular task and they get saved into a single reusable object that can be called. It could be as simple as a select statement. It could be as complicated as hundreds of lines of code with multiple select statements, inserts, updates, deletes, variables, etc. We can include flow controls such as if-else, loops, try-catch inside of stored procedures and user-defined functions as well. Stored procedures might hear them referred to as stored procs or sprocs. If we want to compare this to programming, a stored procedure would be most like a void function that returns no value, or a void method. So the benefits of using a stored procedure: it reduces our client-server network traffic because all that gets passed across the network is the line of code to call the stored procedure. So that's maybe 50 or 60 characters versus the hundreds of lines of code that could be inside of the stored procedure. They give us stronger security because all a user has to have access to is the ability to execute the stored procedure. They don't have to have access to any of the tables underneath the stored procedure, any of the tables that are contained within the stored procedure. It allows for reuse of code. It's easier to maintain having one stored procedure to call rather than trying to update code in multiple places. Stored procedures give us better performance. When we run a query plan or an execution plan is created. For a regular query, it has to be built every single time that query is executed. For a stored procedure, the first time the stored procedure is executed, a query plan will be built. The next time that same stored procedure is executed, SQL Server saves that query plan. So all it has to do is re-execute the plan. So that saves it a little bit of time in building that plan. It already knows how to get all of the data for that stored procedure. It doesn't need to figure it out each time. The stored procedures live inside of our database, so they're included in the backups. A couple of downsides. Stored procedures don't handle dynamic queries very well. You can do them. It's ugly and it's difficult. Stored procedures can be difficult to maintain. If you have lots of versions of them, you could have problems between your dev environment and your production environment. You could have difficulties knowing what stored procedure does what because there's not very good ways to document them in SQL Server. You could have multiple stored procedures that are ever so slightly different because it's hard to call a stored procedure from inside of a stored procedure. But the benefits typically outweigh these challenges. The other thing with stored procedures is it can be really difficult to debug where the problem is because you have your database, you have your stored procedure, and you have your application. So the issue could be in your application, what it's passing to the database, to your stored procedure, or it could be inside of the stored procedure. So there's basically, if you're using stored procedures, it's 2 layers of debugging you might have to go through. So there are system stored procedures inside of SQL Server. They come with SQL Server. They're stored in internal database as part of the installation. They start with SP underscore, and you can see them in the system objects folders in the database. You would use these just like regular stored procedures that you create. So user-defined stored procedures. So these can be created in any database. They could be in your databases, your application databases, or you could create them in a system database. You can use T-SQL, so use SQL to create these, or you can create your stored procedures in .NET and compile them into CLR code and load those CLR stored procedures into SQL Server. Stored procedures can contain data access logic, so how do we get this information? They can also contain business logic. So business logic, things like how do we calculate profit? What do we define as an active customer? Those things are frequently done inside of stored procedures. When we create a stored procedure, we have to follow our general naming conventions. So for variables, functions, and stored procedures, the first character has to be A to Z, an underscore. For variables, we use an @ sign. And then we can use A to Z, numbers, $, pound, or underscore. So some of the same things we used for tables. So to create a stored procedure, we use the create procedure keyword. We have to give it a name. We can specify parameters for it. And we have to surround the body of the stored procedure with begin and end. So the begin and end function like squiggly brackets in programming languages. So let's go ahead and create some stored procedures. Create one stored procedure. So let's create a stored procedure that displays customers and orders. So we're going to start by just writing our query that does that. So select from customers, C, join orders, O, put my star here, come back and clean that up. C.customer ID equals O.customer ID. So let's display the company name, the customer ID, let's put that one first actually. The order ID, and the order date. So I'm going to test this, run it. We see all of our customers with orders. So the customers without orders are not included, but that's okay because this is customers with orders. So to make this into a stored procedure, I'm going to take this query, create procedure, have to give it a name. Frequently it starts with SP underscore or SP. It usually has verbs with it, so something like get customer orders. Generally, if you're working in a company that has a lot of these, they're going to have some sort of standard naming convention that you should follow, or you're going to see something already in use in the database, and you should continue to follow that. So, the procedure as begin, and I'm going to put my end. and then I put my code in the middle, my SQL statement. And I like to tab this in so that I can see everything. And this is currently giving us the red squiggles because it wants to be the only batch in the statement. So SQL Server has this go command. This tells it to execute things individually. So if I were to run everything on this window, first it would execute this, and then it would execute this separately. So instead of trying to execute them all at the same time, it's going to say do this first piece, then do this second piece. So essentially it creates batches. So that takes care of my red squiggles. So I can create this procedure. And if I go into my database, I have this programmability folder. If I go inside of here, I have stored procedures. So this is the stored procedure we just made. And here are my system stored procedures, which there's absolutely a ton of these here. But if you ever need to look at any of them, that's where they live. So here's the one we made. No parameters. So to call or execute a stored procedure, we say exec sp get customer orders. And when I do that, it gives me the results of that query. I could also do execute. Both of these work. So now let's say we realize we need to modify this query to also include the customer, the employee who helped the customer in this query. So I'm going to start by taking my query and adding my employee here. So I need to join two employees. And then I can add employee's name here. So that works. I'm going to come back here, grab my create statement, put my query inside of it. Again, it's angry because I need a go statement here. And this already exists, so instead of creating it, I'm going to alter. This lets me change it. So alter procedure, and we just basically put the new definition of the stored procedure in, just like we do with views. And now when I call this stored procedure, it should show me that employee information as well. That's modifying a stored procedure. So let's talk about parameters and variables. So to define a parameter and a variable, we have to use the @ sign as the first character of the name. That is how SQL Server knows it's either a parameter or a variable. We have to give it a name, and we have to give it a data type. So parameters and variables are local to the procedure. So if I have multiple procedures with the same variable name, it's not linked. They only exist for the scope of the procedure or the statement that you are running. So our data types for these are the same as our data types for columns in the database. So let's create a variable. Let's say we'd like to run this instead of by getting all the records for all the customers and their orders. We want to run it by order date and get what orders occurred on which date. So I'm going to take this query again, and we're going to play with it. So I can declare a variable just in my SQL code here. So I do declare, have to start with @ for the variable name, @ order date, and this is going to be a date time. Now if I do nothing further, it's just going to have a null value. But I can set a value or select a value for this variable. So select @ order date equal, let's pick a more recent one, 5/6/2015. So now I can add a where clause here, where order date, so orders order date equals @ order date. Now to run this, I have to include these statements. And then it'll show me only the orders on that date. So this is not in a stored procedure right now, it's just a SQL query here, so I can do this outside of stored procedures and functions. What will be useful with this, though, is to set this up as a parameter for a stored procedure. So we declare it as part of our stored procedure after our name, but before the as begin part. We'll talk about default values in a second, so in a minute. So let's modify this stored procedure again. So alter procedure. And I put my parameters here. So I'm going to grab this part. So when we have parameters, we don't have a declare. When we have variables, we do. And grab this where clause here. So now my stored procedure takes a parameter. So if we want to call the stored procedure now, we have to list the parameter value after the name of the stored procedure. So I go back to my exec statement. I can't just run this anymore. So it'll give me red squiggles now. It says the procedure function expects the parameter order date which was not supplied. So I can say 5/6/15. and run it. I could also do at order date equal 5/6/15. This way is easier if you only have one or two parameters you need to fill in values for. When you have multiples and you aren't really sure the order, it's better to list the variable and the value for it. Otherwise, you might end up passing in your parameter values incorrectly. So let's talk about optional values here. I can force this parameter to be optional. So if I go to alter my procedure again, if I want it to be optional, I have to give it a default value. So for this, I could have it default to the current date. I could have it default to null. I could do whatever I want. So if they don't give me anything, just do get date. In our database, this isn't going to work. We don't have any current orders. So let's just hard code it to a different. Let's find one that does exist. Seven 4 of 13. If I do this, I can still run this stored procedure for any date I want. But if I don't give it a value, I can still run it. I don't get the red squiggles. And it's going to give me only that order for that default value that we have coded in there. Okay, so that's our parameters. So I showed you how to use a variable outside of a stored procedure. You can also use them inside. We use the declare statement to declare the variable. We have to list the name and the data type. We should give it a value to start. If we don't, again, it's null. So let's talk about user-defined functions. So functions are set up very similar to stored procedures, and they have similar uses as stored procedures. So user-defined functions allow us to create custom scalar functions. We can also create custom table-valued functions that actually returns a table of data. We're not going to go into that in this class, but those are pretty cool. These are useful for code reuse and standardization of calculations or processes. However, in the wild, they're not used as heavily as you might think because they perform pretty poorly in SQL Server. So if it's a really complicated function, it's really the more complicated it is, the worse it's going to perform, because the function runs one time for every row in the query, which is a problem because SQL runs as a set-based thing. It executes things on a set of data at a time, not one row at a time. So when we start adding in functions that execute one row at a time, it causes performance problems. That being said, they are used frequently and they can be really useful. So to create a function, we use the create function keyword. Have to give it a name. Again, we can have optional parameters for our functions, just like stored procedures. With a function, we must specify the data type of the variable that will be returned, but not a name. We have to return a value using a return statement, and it's got to be surrounded by begin and end. So let's go ahead and create a function. So let's create a function that calculates the number of items in an order. So let's start by writing our query. Select from order up details. So the number of items in an order is the sum of the quantity for a particular order. So we'll just do 10250 here. $60 items in that order. So when we have a function, for this, we're going to pass in the order ID. So it's most useful if we can give the function an order ID and get back the number of items in that order. We're going to set it up first with variables and then create it as a function. I'm going to declare my variable. This will be the parameter. I'm going to set the value there. And I have to give it a data type here, so this is an int. And then I can take this and say where the order ID equals at order ID. However, functions cannot return a result set. This is a result set. Functions have to return values. So I'm going to set up another variable for that. That will be what we return. So we're returning the quantity. So call this total items. It's going to be an int. And this is actually going to, total items here is going to be equal to this. So I put it here. Select at total items equal the sum of the quantity, where we've got this order ID. So if I run this now, it'll work, but I don't see anything. So if I want to see the value in a variable, I have to select it. Select at total items. So now I'm going to turn this into a function. We're kind of taking the long road through so that you understand how this works. So create function. Frequently they're called UDF, to FN for function, FX, whatever you want to call this. Again, if you're working at a place that has a lot of these, they probably have a naming convention for you to use or one that's been used that you should continue to use. UDF get order total items. So this is where my parameter goes. My parameter is this order ID. So I'm going to say order ID int. Now I have to tell it what it's going to return. So returns an int. This is what I'm going to return. It's an int. As begin. Put my end. And I'm going to grab this. So this became my parameter. I don't need this anymore. But I do need my total items. And instead of selecting it, because if I select it, it returns a result set down here, I actually just want to return it. So here's my function. You can see it better. UDF get order total items, order ID, turns an int. Here's our variable that we're going to return in the end. We select that variable equal the sum of the quantity, where the order ID is the one we passed in. So in my programmability folder, I have a functions now. We have table valued, scalar valued, aggregate, and system. It's going to be under a scalar valued function because this returns one result per row. So again, you could create custom table valued functions, you could create custom aggregate functions. I'm not sure how you do that, but I'm sure there have been cases for it. So to run this, we have two options. We use it like a normal scalar function, except that we have to do DBO dot in front of the name of it. So I could just say select DBO dot UDF get order total items and give it a value. It tells me 60, so I would want an alias. It's just mad about my IntelliSense, so I can refresh that. Or I can run this as part of a query. So if I have, I'm just going to grab this query I have up here. So then I could do the same thing, but instead of hard coding a value, I'm going to pass it a column. And call it total items ordered. And now that shows up in my query. So if I want to modify a function, it's just the same thing as altering a procedure. I would just say alter function and change the definition. So let's talk a little bit about flow control. So flow control are pieces in the programming language, so in T-SQL, that define different paths through the code. So begin and end define the start and the end of a block of code. So it's kind of like curly braces or parentheses in programming. We can do if and else. So this is the same as an if-else construct in programming. Like in programming, you put generally the squiggly brackets around the start and end of each piece of it. We use begin and end around each portion. So if some statement, begin, end, else, begin, end. We can do while loops. So it's the same as in programming. The code is going to continue to loop and execute until a condition is reached or a break statement is reached. It's got to be surrounded by begin and end statements. And return. So we can return a value in a function with return, or we can cause a stored procedure to stop executing and return to the calling function. We have try and catch. We use this for error handling, similar to try-catch in programming languages. We can use it to trap and log errors. We can also use a throw statement to throw a more meaningful error back to the caller. And we can use print statements. Frequently these are used to print text from stored procedures so that we can use them in debugging. There's no debugger in here. There's kind of a debugger, but it really doesn't work the way you would think it does. So let's talk about a couple of these. If else. So let's go back to the stored procedure. We had this default value here somewhere. Here it is. Rather than doing a hard-coded value, I'm going to change this to null. So if I pass in nothing, this is null, let's return all the results. Return all orders if the order date is null. Otherwise, return orders or the date passed. So this is what happens when it's not null. I'm going to do an if statement here. If at order date is not null, begin. End. Else, begin, end. So if it is null, sorry, not in my programming class today, not these types of comments. Else, return all orders. So I'm going to execute this. If I say get customer orders, now I get everything. But if I do it the date, I get the orders just for that date. So that's our example of if else. While, we could build a basic while loop. So I'll just show you one here. Declare at counter int select at counter equal 10 while the counter is greater than 0. So we'll do a print statement here. So basically, this is going to count down from 10, say greater than or equal to 0, count down from 10 to 0 and print. So we'll kill two birds with one stone here. We've got a while statement and our print statement. If I run this, print statements come out in my messages tab, so it's going to run this each time till we get to 0, then it runs no more. Return, we saw that in our function, would work the same way in the store procedure. Try catch. So if I try to divide by 0, so let's do some math here. So we can assign values this way too. So this would be bad if we had these coming in via a function or a stored procedure, but I'm just going to shortcut it and show you how this works. So if I try to return if I try to run this, I'm going to get a divide by 0 error. So I could put this inside of a try catch. I might want this to be inside of a stored procedure. Sorry, I'm getting confused with my programming languages here. So in here we say begin try, and still have our begin and end, and begin catch. And try. I think I can get away with not having these when I do this. And catch. So instead of having divide by 0 error encountered, which is just the generic, I could print cannot divide by 0. So I don't see it in results, but my messages say cannot divide by 0. So if I have something else here, by the way, ints are really bad things to pick for this, so I should really have decimals. Well, this would work with these numbers. And again, if this is 0, so I could print it, or I could throw a custom error message here. I'm not going to get into the custom error message because there's a number of variables we have to set, but it's kind of nice to be able to throw a better message back to your application than just whatever SQL happens to give you. So that's our flow control. And that's all of our stored procedures and our function basics. So when we'll work on this more in class, we'll go through a couple more in-class exercises. We can do some more demo, and we'll just be doing some very simple stored procedures and functions. I'll see you in class.